So this one is giving the position of a particle is -5t squared. I think it would have been nice if they could have written like s of t equals -5t squared. They didn't write like the whole equation, just gave you that. So anyway, there it is. They're asking for the average velocity. So that is an average rate of change, which just means slope over this interval. So for slope, we need 2 points. We're going to need a point for 0, and we're going to need a point for 3. And so I'm just going to plug those values into the equation. So if we plug in 0, we're going to just get 0. If we plug in 3, 3 squared is 9, times -5 will be -45. And then when you put it into your slope formula, subtract the y values, subtract the x values. I know I've told you you don't have to simplify, but that's for free response. For multiple choice, you have to keep going until you get one of these answers. So this would be -45 over 3, which would be -15. And so that one is C. So number 2, a bug is crawling up a vertical wire. This is the velocity of the bug from 0 to 8. It's asking, at what value of time does the bug change direction? Right, so for all of this positive part, above the x-axis, the bug is crawling upwards. And then for the velocity that's negative down here, the bug is crawling downwards. So the place, or the time when the bug changes direction is at time 6. So that is C. So we changed from a positive velocity to a negative velocity. So we changed direction there. All right, 3, we are given position of the particle is this equation. Times are positive. When t equals pi, what is the acceleration? All right, we can't jump straight from position to acceleration. We're going to have to get velocity first, and then we'll get acceleration, and then we're going to plug in pi. All right, so we're going to need our unit circle here, just a heads up. All right, so derivative of sine would be cosine. So this will be cosine of 2t. And then chain rule, you have to chain on the derivative of 2t, which would be 2. Minus, and then derivative of cosine is negative sine. So the negatives are actually going to cancel, and this will be plus sine of 3t. And then again, a chain rule, I have to chain on a 3. So I'm just going to put that as the coefficient. All right, and then next derivative of cosine is negative sine. So this will be -2 sine of 2t. But because you're doing another derivative, you have to do another chain rule. So we're going to chain on another 2. So if we multiply by 2, that's going to make this 4. Sorry, my T was really wiggly there. Let me make that look a little bit better. All right, plus derivative of sine is cosine. So 3 cosine of 3t. And again, same thing, I have another chain rule, so I have to multiply on another 3. And so that's going to make the coefficient 9. And so now we're going to plug in pi. So if I plug in pi right here, I'm multiplying that by 2, so that is going to make that 2 pi. So where on my unit circle, guys, where is 2 pi? What is going to be the coordinate point for 2 pi? Yeah, good, nice. That would be 1, 0 right here. It's also 0 pi. You go the whole way around, that's going to be 2 pi. So we're right here. Now we want to do sine. So which part of that point is sine? And good, it's 0. The y value is 0. Nice. And if we multiply 0 times -4, we're just going to get 0. So this entire first term just goes to 0, which is kind of nice. All right, plus, now if we plug in pi for this, we're going to get 3 pi. So starting here would be 0 pi. If we rotate to here, this would be 1 pi. Whole way around would be 2 pi. And so if we keep going to 3 pi, that's going to be right here. So this would be 3 pi at -1, 0. Good, cool. Thank you for being with me there. All right, and we're going to do cosine of that. Cosine would be the x value, so that would be the -1 times 9 would be -9. And so 0 plus -9 will give us -9. And so that one is E. It feels like the unit circle stuff is going a little bit better, maybe. We're just gonna keep on doing practice with it. So, and I'm gonna try to do those problems a little bit slower and like more thoroughly than I would under normal circumstances, because I know we missed that last year. All right, 4. Particle is moving, times are positive, position is given by this. We want, when is the particle at rest? So what does that mean we need to do? At rest, how will I figure that out? All right, good. What are we going to set equal to 0? We have to set something equal to 0. Good. Velocity will equal 0. So first we need to get the velocity. Yeah, velocity being 0, that means we're not moving. So this derivative would be 3t squared minus 6t minus 9. We're going to set that equal to 0. That means not moving. And I'm going to go through and divide everything by 3. And then factor. So this is going to split t plus 1, t minus 3. This one's not going to give us an answer because we can't have negative time. And so we just get time is 3. So that one is C. All right, here, this function looks like tons of fun. We're going to use our calculator, though. I see all the decimals there. That's how I know I'm going to be allowed a calculator for this. I'm going to need a calculator. So find yours if you've got it close by. This is velocity that we were given. So this is your velocity function. It says, what is the acceleration at time 3? So to get from velocity to acceleration, we're going to do a derivative. And so on our calculator, that's going to be math 8. And I'm going to type d dx. I'm going to type the function. And then at the end, I'm going to put 3. It says at time 3. So they gave us velocity. They asked for acceleration. So that means we needed to do a derivative. And this is cool. It will literally give you the answer. I mean, you have to be careful typing all of that, because if you type one thing wrong, it's not going to work, which is why it's a good idea to practice typing it. But that's our answer, right? 0.054. They're going to round it up, so it'll be 0.055. So that one is B. All right, number 6. Times are positive. We're given this position function. What is the acceleration of the particle at the point where the velocity first equals 0? Okay, so we're going to need velocity and acceleration for this. We're going to set the velocity equal to 0, and whatever we get, we're going to plug that into acceleration. So actually, let me hold off on finding the acceleration for a second, because we're going to have to set the velocity equal to 0 first. All right, so velocity, derivative of sine is cosine. And then derivative of cosine is negative sine. So the negatives are going to cancel. We get plus sine of t, and we're going to set that equal to 0. And again, we're going to work this out, and whatever we get, we have to plug into acceleration. So I'll need to go back and find the acceleration function too. But let's solve this first. Now you're just going to subtract one of these to the other side. It actually doesn't even matter which one. The point is, we want to find a place on the unit circle where sine and cosine are equal, like an equal value, but opposite signs. So they're going to be an equal number, but one will be positive and one will be negative. All right, so on your unit circle, what would be the sides of the triangle that are this? Oh, good, second quadrant. And the reason it needs to be in the second quadrant is because one of them's positive and one of them's negative. And again, it didn't matter which one I subtracted over here, just as long as they're opposite signs. But what are going to be the sides of the triangle that are the same for your unit circle? Good, awesome. This is going to be pi over 4. And so what would the sides be? I know that's difficult to type. I still want to ask you, though, because I want this to be more like a conversation. Good, root 2 over 2. Perfect. All right, so that's the triangle that we want from the unit circle. And so what we're going to do is find acceleration and evaluate acceleration at this place on the unit circle. All right, which, if we're being particular, this amount of rotation, that is 3 pi over 4. You almost kind of don't need that as long as you have the picture, though. This is the triangle that we're going to use. So let's go back and find acceleration, because that's what they had asked for. What is the acceleration at this time value? So derivative of cosine is negative sine, and then derivative of sine is cosine. When you're dealing with sines and cosines, all these position, velocity, and acceleration all look like the same because they just keep flip-flopping back and forth here. All right, and then, yeah, I know, it looks like if someone who had not taken calculus was looking at this, they would think we were just like making it all up, basically. All right, anyway, so sine here would be the y value, that would be root 2 over 2, but we're gonna make it negative. So it will be negative root 2 over 2. Plus cosine would be the x value, which is negative root 2 over 2. So it would be plus a negative, so this is actually just gonna be minus root 2 over 2. And I feel like that's all okay so far. Here's where this ends up looking really weird. If you've subtracted one of these and then you subtract another one, you've subtracted 2 root 2 over 2. It's kind of like you owe someone $1 and then you owe them another $1, so now you owe them $2. So we've really subtracted 2 of these. And so these 2 cancel, and you just get negative square root of 2. And so that one is A. All right, and then last one, we are given velocity and an interval from -3 to +3. And it says, how many times does the particle change direction? So that would be when velocity changes sign. Because positive velocity means you're moving in the positive direction, negative velocity means you're moving in the negative direction. So when velocity changes sign, that's when we have changed direction. So let's go ahead and look at it. We're going to go to y equals, and let me go ahead and type this in. Actually, I think I just had it and erased it. That's okay. All right, so I went and typed that into y equals, and don't forget the window they gave us was -3 to 3. Yeah, I think I was doing this problem in office hours yesterday, so I already have it typed in there. But make sure you put in the correct window. We're gonna just take a look at it, and all we need to do is count how many times the velocity changes sign, which is what we're looking at. So we have a change in sign right here, that's 1, and then also right here, so that's 2. This one right here doesn't count. It is a place where the velocity is 0, so the particle is at rest, but the velocity stays negative. It stays below sea level. So it's like the particle was moving to the left, stopped, and then continued moving to the left. So it doesn't count as a change in direction. So, so we only get 2, just these 2. And so that one is C.